From moment one, it's worth asking, how does fuel get reliably delivered from the tank into the high-pressure injection system in a V-type fuel injection setup? That's exactly what today's topic addresses: the role, behavior, and replacement considerations of the feed or transfer pump, especially the model 09614020030, often catalogued under numbers like 1,467,030,308. Let's begin with the fundamentals. In any internal combustion engine that uses a V, or similar, fuel injection architecture, the high-pressure injector system demands a steady, pressurized supply of fuel. It doesn't draw directly from the tank in large volume bursts. Instead, a secondary pump, often called the feed pump, ensures that there's always a positive pressure head, free of vapor lock or cavitation. Without this, the high-pressure pump can't function reliably, and the engine's performance becomes erratic. This pump is typically mechanical in design, its drive mechanism often tied to the camshaft, a gear train, or an intermediate shaft. Internally, vanes, pistons, or sliding elements draw fuel from the tank side, push it through one side of the circuit, and maintain pressure to the injection pump. The job is deceptively simple sounding, but engineering tolerances are tight. The pump must operate under varying flow demands, temperature extremes, and fuel quality variations, all while maintaining quiet and consistent operation. The particular pump under discussion, 09614020030, serves many V injection setups. Its design parameters, flow rate, maximum pressure, compatibility with connectors and mounting, must align with the system's expectations. If these attributes diverge, performance suffers. So when does a feed pump go bad? A few red flags often surface. Hard starts or delayed cranking. Especially cold mornings, when vapor issues or weak draw hamper flow. A fuel pressure gauge lower than expected, or fluctuations under load. Engine surge, sputtering, or hesitation during acceleration. Black smoke, if downstream compensations overfuel. Strange noises near the pump housing or in the fuel lines. Because a failing feed pump will indirectly impair the injector system, it often gets overlooked, blamed on filters or injector issues instead. When selecting a replacement, matching specifications is critical. The part number 09614020030 serves as a direct reference, but more important are the functional specs: inlet and outlet port sizes, drive coupling type, orientation, mounting geometry, pressure and flow rating, and material quality. Never assume a visually similar pump will satisfy. Always cross-check. During installation, attention to detail matters. The fuel system should be primed so the pump isn't run dry. Replace seals, gaskets, and any soft lines that may have aged. Use clean fuel and filters. Torque all fittings correctly and in proper sequence. Once installed, monitor pressure under several operating conditions: idle, mid-throttle, full throttle, and listen for anomalies. Small deviations early can indicate alignment or internal leakage issues. The version of the pump labeled as 1,467,030,308 feed pump is essentially the same as the 09614020030 model in many catalogs. The number variation is often due to regional or supplier numbering systems. What matters most is that it meets the same dimensions and performance specs. If you're ready to acquire one, refer to the description below. There's a link to a pump unit I've evaluated. It's dimensionally correct, built with solid materials, and has a track record of reliable operation. Always verify you're getting the correct version for your engine. If you found this deep dive helpful, give it a thumbs up, subscribe for more technical breakdowns, and hit the notification so you know when the next content drops. Leave a comment if you've replaced one of these before. What issues did you run into? What brand did you pick? Let's learn together. Until next time, stay precise and engineered. Let's go deeper into internal mechanics. When the feed pump is operating, it faces dynamic changes. During idle, demand is low, but the pump must still maintain enough head so that the high-pressure section never starves. Under heavy load, flow demand spikes, and the pump must respond without pressure drop. Internally, this requires minimal volumetric leakage and high volumetric efficiency. Temperature swings matter, too. In cold climates, fuel viscosity rises, making the pump work harder to draw fuel. In hot environments, vapor lock or cavitation becomes risk. So sometimes, the same pump must be designed to tolerate both extremes. That's where material choice, internal clearances, and surface finishes become critical. Surface finishes, polished surfaces, low friction coatings, can reduce wear and help when fuel is marginal, low lubrication. Let's compare two hypothetical brands. Brand A uses good steels, tight machining tolerances, and a surface hardening process. Brand B is lower cost, looser tolerances, basic materials. Under test, Brand B might start to leak internally after 20,000 miles, showing pressure drops at high throttle. Brand A might last 80,000 plus miles with consistent performance. The upfront savings of a cheaper pump can result in costly repetition. Next, real-world installation quirks. A common mistake, failing to bleed air or prime the pump. Air pockets in the fuel line will cause sputters or have the pump draw in vapor rather than liquid. Always fill the inlet line and bleed carefully. Another issue, torquing the housing bolts out of sequence, causing distortion and leaks. Always use manufacturer's torque spec and recommended sequence. Use new